nice, intimate audience. So yeah, thank you very much for coming tonight. And I think, apologies, we did have a bit of an error with our ticketing system. I think it went down, which potentially may be why we haven't had as many people as usual. But it's okay. Thank you very much for making it here tonight. We do have two really awesome speakers for you. So we've got, first up, we have got Andrew Phillips, and his talk is called It's About Time. So, it's about time I pass you to Andrew.
Okay, can you hear me up the back? Okay. Well, I just want to explain a few little things about the Go time type. Maybe a lot of people here know a lot about it, maybe more than me, but just have an interesting story about how my first job, where I used Go, and I'm just going to go through that and find some interesting things about time along the way. I wrote this, I had this idea for this talk like years ago, but so it's about time that I actually did it. And it was sort of solidified by a talk Chris Davitt, I think it was Chris Davitt, gave in 2019 about doing talks. But I wrote the slides for this a few weeks ago, and then I've been doing a bit more research recently, and I found there's quite a few mistakes. I fixed most of them, but I've left one in there for you to find. So the first person to spot the mistake, I'll give you a prize. Or maybe I'll buy you a beer at Park Lane or something. Actually, there's probably more than one mistake, but there's one that I know of. And I guess if you find more, then I can pretend that I put it in there on purpose and I'm just testing you. But anyway. And there's a little bit of C and C++ code. I don't know how many people know that, but it's sort of part of the story, so I have to go along that route, unfortunately. But anyway, once upon a time, I started a new job about 5 years ago. I was actually employed as a C++ programmer. Oh, I've got it up on the screen. Thanks, Stu. Yeah, my first job was to write some code gen to generate Go code, and I sort of wrote that. Then I wrote a package to implement it's a package to talk to our AMQP server. The section I was employed in basically does the infrastructure for a whole lot of other groups. So like there's about 6 different programmer groups. They all use their own. They're all sort of siloistic. They're all in their own little groups, and they all use their own language. So we have to support through our message passing system all these different languages, like there's C#, Python, PHP, all these different languages. And the group that was using PHP decided they wanted to use Go instead. And that was just when I joined. So I was given the task of doing the Go code gen, doing the package, getting it all working. And within a couple of months, I became an expert on Go, which I found was good. I actually played with Go a little bit before. I sort of was a bit my boss. I sort of, yeah, it's all right, but I didn't really get into it enough to really appreciate how simple it made things. Anyway, so speaking of my boss, or he wasn't my boss at the time, but he was sort of the technical lead in the company, and he was basically who employed me as a C++ programmer. But then, anyway, I'll get on to the next slide. Every good story needs a villain. So I've called him Mr. X. Is this being recorded, by the way?
It is.
Oh, so I'll say he's not really a villain. He's quite a nice guy, really. But he's a bit of a fanatical C++ programmer, and every time I'd talk, he'd ask me a bit about, like, he'd do code review of my code. I'm not sure how much of it he read, but he'd ask me a bit about, how you do that in Go, and I'd say, oh, you know, and he'd always manage to pinpoint problems with Go, and he was always saying, oh, geez, Go is such a terrible language, and I was trying to say, well, no, it's not that bad. It's you just got the wrong picture on it. But I mean, like a lot of programmers, you know, they're fanatical about what they know, and you know, you couldn't really change his opinion. But so one day I was just explaining to him about this code that I wrote to do timeouts. So essentially, like, I've been working in C and C++ for a long time, and this is how I'd always written timeouts. And probably not the best way to do it, but anybody have any questions about what's wrong with, or have any comments about what's wrong with this code? If you'd have to know C to, I mean, this is C, but I'd probably do the same thing in C++ 10 years ago.
Time can go backwards outside your program.
That's the main point. I mean, there's problems with the C code. Like, you can't really assume that time's in seconds. Like, time is, this time function is returning the current time, but all C compilers return it as seconds since 1970. Yes?
Not that it's unlikely to happen because of, you know, time in the future, but you could also wrap by doing that plus 10.
Plus,
You could overwork time T and wrap around. Obviously, if that's your problem, you're in the future. That's your problem.
time T, well,
That's another problem.
in the first C compilers I used, time T will wrap in 2038 or something.
Yeah. So in the future, there's a problem.
But I don't know. I'm not sure. Is time T still 32 bits? Or, I mean, there's time T 64. Most compilers support that, but I'm not sure if the default time T is usually 64 bits now. But anyway, this is C. I'll show you the equivalent Go code, which is what essentially what I wrote. And it doesn't have problems with the fact that you're assuming seconds, because this is all, like, we're using a duration of 10 times time per second, adding it to the time now. So if anybody, should I explain the code in detail? You're working out the end time by getting the current time, adding 10 seconds to it. And then while the current time is less than the end time, you're doing whatever. So, as Mark said, the main problem with writing it like this is, it's using the system time, and what if the system time changes somehow? Has anybody got any ideas how the system time might change? Sorry?
Daylight savings?
Daylight savings? Well,
Manual filling.
that's what I was thinking, daylight savings, but actually daylight savings, all times are in UTC, so the time zone doesn't really affect the underlying time. Pardon? Sorry? Leap seconds is the main one I was going to talk about later. But I mean, if you're just running like most servers, the operator won't go and change the time manually. It'll be automatically updated by a daemon. Like we use NTP daemon, which automatically changes the time. So, but theoretically, you could have the administrator or someone just go and say, oh, I want to set the time back or forward, or I think it's 30 seconds too fast, so I'm going to set it back. But if this code's running on a server, which my code would be, the NTP daemon is all the time checking its nearby computers to find out what the current time is. And well, we have two of our servers have GPS cards in them, so one in Europe and one in Australia, and so they basically get the time from the GPS satellite, which all GPS satellites have a atomic clock, or 2 atomic clocks, I think, inside them. So basically, unless we have had the problem that the NTP daemon has crashed or stopped working properly, and so the clocks are completely out, or maybe 30 seconds out, in which case, when you restart NTP, it'll say, oh, shit, I'm really out. It'll jump the time. But if it's only like a few seconds out, it will try to slew the time so that it gradually gets back to the right time over a couple of hours or so. Anyway, I'm getting off the track here. So, system time might change. I've already covered that. So the main way that the system time will change on a server is that you'll have a leap second. So what's a leap second? Well, I'll get into that later, but basically every now and then they add a leap second at the start of the year or the 1st of July. And since 1970, we've had about 30 leap seconds added. So basically they're saying the way the Earth's spinning is changing slightly. So over a whole year, it's just a second out, or once it's 0.8 seconds out, they add or subtract a leap year. So since 1970, there's been about 30 leap years added. So every time that happens, all the UTC time all over the world goes back 1 second. Yep.
Yeah, they've redefined the time since, it's now the time since 30 seconds past the beginning of the 1st of January 1970.
Yes. Yes, basically they've...
Rather than being an absolute number and then saying that the time zone now involves an extra second, which is how I would have written it, but the whole world disagrees with me.
Well, I mean, there's a debate about now whether we even really need time seconds. Like,
It's about to go backwards, by the way.
yeah, I know, because the Earth's been speeding up since about...
No, there's been a slowdown recently, and they're talking about maybe they're going to do an extra one.
Yeah, but when the Earth slows down, they have to add an extra. They have to set the clocks back a second.
Other way.
And so since about 2017, the Earth has actually sped up to its normal speed or even a bit faster. They don't know exactly why, whether it's, well, it's mainly to do with ocean currents, I believe, but there's a lot of factors that could be involved, including the moon, which I was going to talk about later.
The Fukushima
Earthquakes, yeah?
earthquake sped up by 10 microseconds.
Yeah, I read that somewhere too. And the earthquakes, and could be the Earth's core actually spins faster than the rest of the Earth. So it could be something to do with the Earth's core, and they also think that things in the mantle moving around change the speed, and the fact that if glaciers on the poles are melting, that the water will move towards the equator, and that will make the Earth a bit rounder, and so it will. Anyway, we're getting off the track here, but yeah, leap seconds is the main problem. Let me go to the next slide. Oh yeah.
Sorry, was there anything wrong with that code?
Yeah, it was
Apart from the externality.
well, when I wrote it, there was.
Well, you're also assuming that your do something returns quickly.
Uh,
Otherwise, you don't have your 10-second guarantee. So
Yeah,
if you
Okay, it returns.
exceed 10
That's true.
I mean, that was what I thought was wrong with the C version.
Okay.
But, I mean, yeah.
The do something is just a
It's-
what
it
wasn't
doesn't
part
have
of.
time.
Yeah, just say it happens. It runs in a nanosecond. Okay.
It doesn't fail badly.
No, but if it takes 100 seconds,
No.
timeout thing is...
I mean, this could just be code. It's not necessarily a function. It just could be code or whatever. Basically, I'm just talking about the time.Now, the before function. So before, in the version of Go that I was using, time.Now was returning the system time. So if someone changes the system time, this timeout won't work because, if they move it forward, then it will time out immediately. If they move it 20 seconds forward, time out immediately, and do something will never be executed, or you'll get some sort of failure. Like if you're waiting for some sort of network event, it will fail immediately, whereas it should have waited for longer. But if you set the time backwards, it might wait a long time or forever. Or essentially, you'd think, oh, it's just frozen because it's just still running. But did anybody hear about the Cloudflare incident? I think, Gary, is that the one you were mentioning to me last time? Yeah, it was fairly famous. I didn't hear about it at the time, but basically what happened was that Cloudflare, which is a fairly large company which has servers, hundreds of servers all over the world, they had some Go code running and it crashed when the leap second at the end of 2016 happened, because time went backwards, and they had some Go code there which panicked when time went backwards, basically. And so I guess it was a bit of, I mean, I'm not blaming Cloudflare because they were very upfront about it. Like a lot of other companies might have just sort of brushed it under the mat and said, oh yeah, we had a bit of a problem, but we fixed it. Cloudflare, when they had it all fixed within an hour, I think, and then they actually went and published the code, said, this is what the code we had, this is how we should have written it, and and all this stuff. But it was a little bit of a bad publicity for Go because they said, because it was all Go code, and it was all based on the fact that Go, at that time, when you call time.Now, it returns the system clock. So the system clock, during that leap second, went backwards.
When they do these leap seconds, do they send out an SMS or something?
Well, I mean, they do send out, I think NTP actually, the time daemon actually sends out information to say there's a leap second coming up. But you have the option to ignore it, but I think what happened was, I think Cloudflare were using Linux servers, and they just got the NTP message, and then they passed it to the operating system to say, oh, there's a leap second coming up, and Linux just says, oh, just set the clock back a second. Like, computers don't have, atomic clocks have the ability to have a 61-second minute when this leap second occurs, but all the other computers in the world just have to recycle the same second and pretend it didn't happen. But yeah, so it was based on the fact that Go just returns time now as a system clock, and you're relying on the system clock being monotonic, which it isn't. You know what? Everyone know what monotonic means? It just keeps going up, never goes down. And the way, I mean, if your Go code was running on GCP or AWS, then it automatically, what they do nowadays is when there's a leap second coming up, they ought to just slow down the clock 12 hours before, and as you go through the leap second, it's like half a second down, and until 12 hours after the leap second is finished, the clocks are back again. But that's technically not really UTC time, because you're actually, UTC time goes, well, theoretically it has an extra second at the end of the last minute of the year, but I guess what Go was relying on was that system clock was monotonic, but or if you do write code that uses system time, you write it flexibly enough that it doesn't crash, doesn't panic if time goes backwards, which is what Cloudflare didn't actually do. Anyway, in Go 1.9, they possibly, or probably mainly because of the bad publicity of this incident, they changed the time type in the middle of 2017. Oh, I was going to cover leap seconds first. We could probably skip all this. I think I've already mentioned most of it. Yeah, so we've had about 30 leap seconds since 1970, and how much time have I got left? And leap seconds are caused by the rotation of the Earth. So the speed that the Earth spins doesn't always stay exactly the same. As Gary said, the earthquakes can change it and all sorts of stuff. And while I was researching all this, Oh, here we are. What causes Earth's spin to change? Well, the major thing, I think, is ocean currents. And in fact, apparently when the Earth speeds up is linked to La Nina. So when the Earth sped up in around 2018, we should have expected lots of rain on the east coast of Australia, which we got. Anyway. And also, leap seconds are affected by the moon, but this was part of my main presentation. Is anybody not interested in this? It's sort of a bit of a diversion, but I found it really interesting. If you're not interested, just go and play on your phone. Did anybody see Neil Armstrong land on the moon? Anybody here? Live, yeah.
I grew up believing I watched it. But my mum recently said that she was breastfeeding me at the moment. How old were you?
Well, I remember watching it in the... Sorry?
I wasn't looking at the screen.
Oh, well, you should have been paying attention. It was a very important moment. I was actually in the library of my primary school watching it on TV, but it was just all these black and white images. I didn't really know what it was. But anyway, one of the important things Neil Armstrong did was he put a retroreflector on the moon, which is basically a mirror which, when you shine a light, it reflects it straight back the same way. And what they've been doing ever since is shining lasers at the moon and measuring how long. And nowadays we've got such accuracy with lasers, we can measure the distance to the moon within a millimetre. And they know that the moon is moving away exactly 3.8 millimetres every year, which means because it's moving away, it's like a skater spinning. If you put your arms out, you slow down. So as the moon moves away, the Earth has to slow down because some of the angular momentum for the moon to move into a higher orbit is for the Earth to spin not quite as fast. And the way, the reason that the moon is moving away is to do with the tides. I think I understand it, so if anybody's interested, I can explain it to you later. But basically, the moon is causing the Earth to slow down. But does anybody have any questions or comments?
As the moon moves away, does that mean our average global tides get higher or lower? Like the range of them, does it like shrink?
Something I haven't thought about. Probably lower because
It gets away the gravitational effect, so
it'd be less because
So can we look at the history of tides and actually see like a slight decrease, or is that also going to be like?
I think it'd be negligible because when you think about it, like the Earth has been slowing down. Well, the moon was.
Moon's moving away too. Permanently moving away.
That's what I'm saying. The moon. Well, the moon and the Earth are separating 3.8 millimetres a year, but that's happened ever since the whole thing formed about 4.5 billion years ago, and like I think I read somewhere that during the time of the dinosaurs, a day was 22 hours long. But when you think about how long ago that was, it actually means that the Earth the spin doesn't slow down very much at all. And actually, it'll take 50,000 years before for the effect of the moon will mean that we add a leap year. So, sorry, a leap second. So I was a bit misled because I kept reading on the internet that leap seconds are caused by the moon, and actually, if you go to the Wikipedia, who believes Wikipedia pages? I believe them mostly, and they usually have a lot of good information. But occasionally, you have something like this, where this bit highlighted in yellow says, well, this is talking about tidal acceleration, which is basically how the tides cause the moon to move into a higher orbit and slow the Earth down. And it said this led to the introduction of the leap second in 1972. Well, that's not really true because it will be another 50,000 years before we have to worry about UTC time being affected by the moon. So this was sort of the crux of my this previous slide was the crux of my talk, or at least an interesting sideline, but it's actually wrong. Anyway, so leap seconds, I'm running out of time here. So how do we handle leap seconds? Well, NTP normally gets told about leap seconds and then passes that information on to Linux, and then Linux, or different versions of Linux or different operating systems do it different ways, but generally they just set the time back 1 second, as in that blue arrow there. But sometimes they just hold the time at the same, hold the system time at the same time for a whole second, or maybe they just slowly increment it to a little bit. The other thing is the smearing, which is represented by this red line, which is what AWS and GCP use. I'm not sure what Azure uses. I don't think they do smearing. What we do in our work, we just, any leap seconds that come along, we just ignore it, and NTP will say, oh shit, I'm a second fast, I better slow my clock down. So it rapidly tries to, like over half an hour it slows down, and then it doesn't do a very good job because it slows it down too much, and then it like takes several hours before it to get accurate again. Luckily, since I've been working at this job, we haven't had a leap second, and I don't know if we ever will, the way things are going. So there's, well, my idea was, actually, why don't you just stop all computers in the world for a second, and then you won't have to worry. But maybe that will have other consequences. This is this second solution here. Who?
It's a movie, don't worry.
Yeah.
Anyway, or the other way to solve it is for like all these workarounds with the slewing and all this, the smearing of leap seconds and all this is to work around the fact that there's code out there that uses system time assuming it's monotonic. Whereas maybe the solution is to write the software properly, and that's why in C++11 there was a thing added called a steady clock, and that's why Go 1.9 added monotonic clocks in 2017, I think. So,
5 years ago, around
sorry?
now. It is 5 years ago around now.
Yeah. Anyway, this is when my boss told me I was doing it the wrong way. This is what he had in mind because he was really into C++. This is how you would do it in C++. You'd use there's a system clock and a steady clock. So you'd use a steady clock. You say the end time is a steady clock now, which is the current time, and then you'd add the duration, which is this thing here. This is a generic or a template or generic type, which takes another generic type, which is milli, which is a ratio type, and I couldn't work out how to get seconds, so I said 10,000 milliseconds. And you can see it's a little bit complicated, whereas in Go, I took great pleasure in saying to my boss, oh yeah, I solved this problem. This is the code I used. And if you look at this code, it's exactly the same as the code I was using before, but all I did was downloaded Go 1.9 and rebuilt it. Anyway, and I think you can see that I guess maybe to a C++ programmer it's not simpler, but that looks simpler than the C++ code, don't you think? Anyway, I do. So how this works is that time.Time now has 2 clocks, or it can have 2 clocks. Has a wall clock and a monotonic clock. And the layout is like this. I'm not sure about the first one. This is the layout before Go 1.9. I'm not sure that's correct. I don't know if anybody knows what it was, but Mark or... But I know that this is the layout in Go 1.9 and later where you've got a bit which says, do you have a monatomic clock? And if you do, you've got the wall time is in the other 63 bits of that. These are all 64-bit words or whatever you want to call them. So and the next 64 bits is a monotonic clock, which always goes up. And the last thing is the time zone pointer. So I don't know if you don't know, all times in Go have a time zone pointer as well, or a location they call it. But the only way to get, well, you can have, even in Go 1.9, you can have this monatomic bit not set, which means this wall time, well, these 33 bits become 0, and this becomes the wall time, which allows you to have all 64 bits of seconds, which basically covers all times for plus or minus 50 billion years, so it should be enough. And you still got the nanosecond. So you can basically have any time within the history of the universe up to 50 billion years in the future represented to a nanosecond. Anyway, I think that's pretty cool that you can do that. Unless you want, if you want to use monatomic time, you can't do that. But if you want to use monatomic time, you have to have a smaller wall time, which is only from 1885 to 2150 or something. Anyway. Oh, there, you've got that there as well. So I think I've run out of time now anyway, but I'll just quickly go over this. Yeah, if you're doing timeouts, this is the original timeout code, but just using a context which, I mean, there's not much point for that, but context is really useful if you're waiting for I/O from a channel. So you can, if, for example, in this second bit of code, if some chan never returns, then you can have a context, this timeout context will allow the select to be exited. Yes?
You need a read from context done there. Is that a mistake?
Oh, yeah. Sorry, yeah. Well spotted. That's another spot. Thanks. No.
Oh, you could have said yes.
That's another mistake I added. I deliberately added that one just to test you. Yeah, right. Good spot. All right. So yeah, context is useful. Sleeping. I hope I've never seen this in Go code, but busy loop to. I mean, a sleep is just like a timeout, but you're not doing anything, sort of. So this sort of thing used to happen in C code quite a bit, where someone would want to wait for 10 seconds, so they'd just run a loop, which is a complete waste of CPU power.
The busy loop is going to chew up your CPU.
Yeah.
It's good for keeping it equal.
I've actually, in not this job, in my previous job, there was running code, production code, which had a busy loops in it. It was written in C. I mean, I don't know how old the code, it was probably 30 years old, the code, but it was actually running in supermarkets, checkouts, like at least, 5 years ago, 6 years ago. Obviously, everyone should use time.sleep, but I read somewhere that it's better to use time.after. I'm not sure if this is true. Marcus. Sorry?
Wouldn't time.sleep just call time.after and wait for the channel to return?
I don't know. I think I did look at time.sleep. I think it just. Oh, no. Time.sleep. No, I'm not. It calls a system.
The problem with time.sleep is
Yeah.
what's wrong with it.
Oh,
I've been in an investment bank in London where we bought £1 million worth of computer gear to prove to the guy that his code was bad. Because his manager was better than our manager.
and he just showed that the profiler showed that time.sleep was taking all the time.
Yeah, and then we actually
But-
found out that the gear that we had originally was 10 times good.
Well,
Someone else's money.
I mean, I think time.sleep is a code smell. Like harking back to my previous job where there was there was sleep calls, Windows operating system sleep calls all over the place, and basically they were there because they had some sort of race condition and they couldn't work out how to fix it, so they added the sleep in and they found that it started working. So anytime I see a sleep, I think that's a bit of a smell anyway, but I guess there could be valid reasons to do time.sleep. But what I read was that time.sleep will actually, maybe it depends on the operating system or maybe it's just an older version to go, but time.sleep will will block in the operating system so that every time you call time.sleep, you'll create an extra thread which will block, and so the Go runtime will have to create another thread to run another Go routine so that it can keep its Go maxprocs running Go routines running. Whereas time.after doesn't do that. But I did some tests and I couldn't prove that either of those is better. And I think Mark is saying they're the same.
If you call the C version of sleep, that's bad. If you call time.sleep, that's integrated with the schedule.
Yeah.
So
Okay.
it's perfectly fine. In fact, probably uses less resources. The problem with time.after is if you call that, it's going to probably have a Go routine, which is waiting for that timeout to then tell you, here's your timestamp, and you can't cancel it. So if you finished with it early, it just sort of hangs around in your program. So you can actually run out of resources if you have a long timeout and call it many times.
Yeah, but the Go routine, but...
Time.after, so often time.after I find is a code.
Well, it must time out after 10 seconds and send a message.
Yeah, but you can allocate a lot of those in 10 seconds.
In some circumstances, if you're doing that, like say 1 million times
Yeah.
a minute, and you've got like a timeout of 2 minutes, you just have a whole bunch of these just floating around in the background.
Oh, okay.
And so if you're doing that, then it's better to use a timer, and then you can stop it and release the resources.
So time.sleep is better than
Yeah,
time.after.
time.sleep is integrated with the scheduler, so
Ah, okay.
yeah, I mean they're both fine.
Maybe I misread that.
Yeah, and like if it's a really old version or you're calling the C version,
Yeah.
that's bad.
I suspect, yeah, okay. Anyway, that's interesting, thanks. I think that's probably another mistake. I wasn't sure about that one. I think I better speed this up a bit, but this is an important one. Like time is, most of these things I've been talking about, most beginners or even experienced Go programs don't even need to worry about. They just use time and am I doing something? And it just works. But one thing is time comparisons. Because you can only compare comparable type, well, time.T is a struct and it's comparable because it has all comparable values in it. I don't know, I don't want to go into comparable at the moment, but so you can actually do this second thing, which is compare 2 times, but what happens if you could have 2 times which are exactly the same time, but they're in different time zones, so really they should compare the same. So that's why they've created this t.equal method, which allows, given a time, it allows you to compare it to another time to see if they're exactly the same time. And I mean, I've never actually had to, I can't really imagine many situations where you'd use a time as a key to a map, but I guess it's possible. And in which case you're probably better off using, getting the Unix nano time out of the time and using that as the key instead of the time type itself, for the same reason that times are not comparable. Better quickly, there's not really much more. Oh, performance, well, because of the monotonic thing, some things do run a bit slow because if you're adding to a time, then you've got to add to the monatomic time and the wall time. But basically, I don't think it matters a lot. What else could I? Is there anything interesting there that anybody can see? There's a tiny time package if you want to use it, which is on GitHub. But it's like the C time, which only supports a range of 140 years or something. Anyway, so actually, oh well, you could probably skip all this. It probably doesn't affect you unless you're actually doing something with times and performance is critical to you, or memory use is critical to you. There is a gotcha which I've discovered that if I get called time.now, it gives you a time in the local time zone. But I was thinking, oh, I don't really want a local time zone. I want it in the UTC time zone because that will set the location pointer. I'll go back to the...
Using time.now call.
Sorry?
Using parentheses in previous slide.
Oh, it's all right. I'll go and have a look in a sec. But this pointer, if you have a lot of these in the heap, then every time the garbage collector looks at this, it has to go and look at this pointer. And so if you can set it to nil, you can save a bit of time. If you have millions and millions of times on the heap, you can save a bit of time by setting all your times to UTC. But then I found out that UTC is not very good because it turns off the has monotonic time, the has monotonic flag, and so your time differences revert to the wall time differences, which is pretty... Anyway, I might create an issue to fix that. Sorry?
Is there a reason for that?
I couldn't work it out. I mean, there is a comment that Russ Cox made somewhere about, I'm going to do this, and there are some tests fail, but I can never find a reference to the tests or anything. And I don't think it's a good idea, and I might create an issue to fix it. It might sort of be backward incompatible, but...
Something to do with the fact that UTC is meant to be universal.
Sorry?
There's something to do with the fact that UTC is meant to be universal, so changing things.
Well, it does it if you change the time zone for anything. It just turns off the has monatomic time. And the argument was that if you're changing the time zone, you're probably using it to display times, not to do comparisons. But I think if you set it to UTC, you're explicitly saying, I'm not worried about displaying times. Anyway, that's just my opinion. It's a bit of a gotcha, because I actually, in my code, I changed a lot of the calls to time.now, and I added .utc, and then I only realized 2 years later all my time differences were using wall time, not monotonic time. Anyway. There's another problem with when the computer gets suspended. It's a very technical thing. Linux behaves differently to Windows, but probably won't go into that. Anyways, in summary, Go makes doing a lot of things simple with time, and when I first used time, I didn't realise that changing the time zone, or I didn't really understand why the time zone was attached to the time. Because if you change the time zone, it doesn't actually affect the time itself. But it is useful to have a time zone attached to times sometimes, even if you don't use it most of the time. There's other cool things about, like there's lots of blogs about how time works. Like I really like the way that you can just create this, like any time using this special format of January, like 1, 2, 3, 0. Oh, that's wrong too, isn't it? 304. It should be 30405. Sorry, I just typed this in very recently. But I should know it off by heart because I use it quite a bit. Yeah, okay. Well, the pitfalls of using time is, yeah, always you always use time.equal or t.equal, the method, rather than using comparing two times with the equals operator. If you have performance issues, you might have to look under the hood how it works. Yeah, that's basically it.
Nice one.
Any questions? No? Any feedback? Any more errors you noticed?
You forgot to call nouns in
Sorry?
the previous functions.
Where is the error?
Previous slide. Time.Now. This function.
UTC and
All right. So
Oh, yeah, the quotes. Yeah, sorry. The brackets.
let's go have a break, and then I'll very quickly talk about APL afterwards, because I hijacked the Go meetup, and this is now an APL meetup. You all speak arrays now.
APL.
Yeah. Oh.
overloading the subjects.
Let's try this.
Yeah, mention. If you read providing what time is it? The maybe got hashtag, then that's the
Okay, I think we're ready now for our second speaker.
I have no idea why this is not doing.
Anyone would like to take their seats at the back, if that's okay?
It's just out the door first.
So how do I go full screen?
Time travel. Leap century.
Enter full screen. Command F. Nope.
Okay, so thank you very much, and thank you very much for Andrew's first talk. That was really interesting. Thank you very much for the talk about time. We've now got a talk by our very own Chewy, all about arrays, which is not the pay rise kind; it's the machine learning kind. I'll pass over to Chewy. Thank you.
I must first apologize because I literally wrote this in a very, very last minute. I've always had this idea for this talk, and Gary, Andrew, and pretty much have been asking me to talk about APL, but that's getting ahead of myself. So I wrote this talk last night, so there may be some errors, and well, sorry for the errors. Right, so let's start with what how we think about the world, right? How we think about the world is that we build models in our brains. We build models of concepts. We build a model of what a mobile phone is. So even though a mobile phone may come in different form factors, we will eventually recognize them. And we build models in the brains. And when I say models, I mean they don't exist physically in your brain. They exist ephemerally in the connections of your neurons in your brain. Now, the thing about forming models is that it's called abstraction. You can form a model of something, and then you can refer to it like using names. Your name is so and so. I don't describe you as a collection of subatomic particles in this with this specific Schrödinger equation. So and the way we think about things is that when we form models of the world, we need to be able to represent those things, and different ways of representing the models of your world have actually changed how we think about this. To take this to the most extreme, you guys must have heard of, what is it called, Damok? No, not Damok is the name of a Star Trek episode. Linguistics guy, come on. Yes, Sapir-Whorf. Yes, Sapir-Whorf theory, which basically says that the language you speak affects the way you think. Now, that's largely, in human languages, that's largely debunked. But I do suspect that this comes into play in programming languages somehow, and Gary and I have been talking a lot about it. So there's this guy, Ken Iverson. He won the Turing Award, and this is his Turing Award speech, notation as a tool of thought. So you can think of writing things down, and the way you write your thoughts down is actually going to change the way you think about certain problems, right? If I were more, well, I actually live in Marrickville, so I'm the hipster kind. If I were more hipster kind, I would say Steve Jobs used to say that the computer is a bicycle for the brain. Now, so what have I been thinking about, right? So over the last 5 years, say 2017 till now, 2015 till now, I've been thinking about differentiable programming. So the way we do programming now is we tell the computer to do x plus 1, and then the computer the results, and then return us the results. Differentiable programming means that you want to be able to get the gradients back. You want to be able to differentiate your program, like do dy dx on your program. And the most famous differentiable program framework is TensorFlow, which, by the way, came about 2 months after I announced Gogonia in golang-syd. So, yeah. So I've been thinking about how we can represent thinking about these differentiable programs. And the biggest use of these differential programs are, of course, neural networks, the AIs that you see, and the deep learning stuff, but it goes so much more than just the matrix multiplication stuff, right? So I gave this a thought, and I wondered how I was going to represent them. So I tried various things. I tried it, I created an ML, the meta language, a Robin Milner meta language version of this differentiable programming paradigm, right? And let's see, where is my mouse? So this is how it looks like. Here I'm declaring a matrix of 2 and 2, 2 by 2 matrix, which is of float 32 type. Sorry, I have to use recordings because I couldn't find my repository. So yeah, so this is now I can rename the matrix. I can create, or I can actually pre-fill it with some initial values like a Glorot sampling function. And now you can see that the matrix is actually filled with things in it, like drawn from a normal random distribution. So this is the programming language I wrote, and it is very ML-like. It has all the types. It has Hindley-Milner types. It has all these funny things that you don't normally see in like C or C++ kinds of programs, because that's the Stepanov world of types. Is a completely different world of types from the other, like the academic programming language groups types. So here is, for example, a very ML way you can do. I'm doing x times y, and now I'm also going to say I'm going to differentiate that colon delta partial is it's a differentiation function. And once you get the differentiation, once you can do differentiation, you can also get the derivative as you perform the operation. And so this way, this is a basic idea of what differentiable programming is. You can write your functions, and here in this case I'm using x times y, but you can think of many other different kinds of functions that you can work backwards and compute the equivalence backward gradient. If you're familiar with category theory, the backward pass is a basic pullback, right? So ML seems to be quite usual. The usual things that people do when they create new programming languages, but it didn't quite sit well with me, other than the fact that it's a pretty cool name. MLML.ai is very nice. So I tried a different thing, which is Algol. I also tried it as a Lisp, but I couldn't find any recordings. I couldn't find my repositories for it. Yeah, so I left this as a bonus slide. I also created an Algol, which is a Go-like language with generics, by the way, using the Go parser, a modified version of the Go parser. So this is how it looks like. So I'm defining func A of type any, of a type variable A, and returns A. This is a generic function, generic identity function. For the sake of the interpreter, I needed to add these colon things to tell the interpreter that I'm done with entering my code now. So you can see that there's a type, there's a for all A to A. That's more than, I can't remember the name for it, but yeah, anyway, parametric type systems. So here I'm writing an add, and you'll note that I don't actually write the return type, because I basically augmented the built-in Go type checker to use a HM type checker, which I wrote, right? So here now you have a function that is an int to int. It's basically a concrete function that you generate on the fly. And you can add 1 point, and you get a float version of this add function. Now, this is just me showing that the add actually works. And you can put any number in there on any types. So they work, but to show you that actually the power of genericness, is that I'm going to use the identity function. So it not only works on like numeric types, it works on any type. Right? So I call the identity function of I to get the add1i identity, which is itself, which you then can call, and it will still work as a function. So this was 4 years ago. I I've written a number of generic, capable Go-like languages since. Most of them have to do with, being able to think about and reason about these differentiable kinds of programming. So that brings us to the next paradigm that I did, which was APL. Who knows APL? No? Okay, so APL is an array programming language, and this is the entire program to write John Conway's Game of Life. It's in one line. It has a lot of strange characters that you may not recognize, but once you do understand like APL, like this is mirror, rotate, and that's a last argument, omega, and this is, for example, this is for each. You read this as for each, you read this as mirror for each. So you flip across the x-axis on the matrix for each. And then these are like the patterns, 1, 0, -1, and then you flip horizontally. Yes, and this dot, compose dot, and rotate. Well, not rotate, flip, mirror, whatever. Flip horizontally. So a bit of the history of this APL. So I started in 2018, and it sort of languished around. I go back to it from time to time. I use it as a calculator. It's an amazing calculator, by the way. And then until early this year. Earlier this year, I had COVID, and then my arm. Some of you may know that I had like very serious pain in my arm, and I couldn't type on one arm, on one hand, right? So I thought, if I can type less, this will be better. So I completed my initial version of this. It's called Mango, but Apple Mango, But I hired someone from Sri Lanka to help me finish the program, and then recently, a couple of months ago, I started refactoring everything into V2, which brings me to today. The demos that you're about to see is very, very raw. It's basically a from-scratch rewrite. So it's not quite complete yet. Now the new version of the language is called Iverson notation in Go or INiGo, and if you've got such a name, you clearly have to have an interpreter whose last name is Montoya, right? Yeah. Prepared to die. Yeah. So, why APL? Why? Sorry?
The Princess Bride.
Ankit, you're a bit too young, are you?
No, they're not.
Okay.
It's all right, it's not remake it.
No way. Oh. Okay. So, why bother with an APL, right? So, the key about APL is, and this is for real, the APL logo is this. Okay. I'm not joking. The APL, it is for real. This is the APL logo.
And the Beatles haven't sued them yet.
What? Oh, Apple Records, yeah. No. So, the reason for me to use APL is that it forces you to think different. And APL is, an Iverson notation. So what it does is it doesn't do abstraction. It subjugates the details. So let me take you for an example, right? So this function, these 3 characters, is 3 different functions. Times, everyone knows what times is, and everyone knows what plus is, and what does this dot do? So I'll give you a hint. This function, we read it as matrix multiplication or matrix vector multiplication, or inner product. So you take two arrays, you inner product it, and you get one number out of it. Okay? So what the dot does is it's a function, it's a higher order function that takes 2 other functions, times and plus. And when given multi-dimensional arrays, what it does is it takes the first row and matches it with the first column. The second row matches with the second column. Then it applies the function to the right, multiplication. So you get the green bits times the green bits, and the yellow bits times the yellow bits. So when you times these things together, you have an array of 3 things, right? So after that, what the plus does is it shrinks those 3 things into a single number. And because there are two of these, you've got 2 numbers, you've got an array. So this is matrix multiplication. But if you think about it, this is like pretty standard things that most programming languages can do. What's so great about this? Why do we break down? Why do we break matrix multiplication down into 3 functions? Well, the key to note is that the dot takes 2 binary functions. It means binary means it takes like 2, an arity of 2. You guys know what binary functions are, right? Plus is a binary function. You need 2 operands, right? So it takes 2 separate binary functions and then applies the general pattern of taking 1 row, taking 1 column. Okay? So you can do things like this. Compose dot times. Compose means put things together. Literally write them next to each other. Times is multiplication. So if you've got 1 row of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, the other row 1, 2, 3, 4, 5, 6, 7, 8, 9 times, you times each of them together, and then you compose the results together. What do you get? You get a multiplication table. This is outer product. And you can change this to any binary function. If you want to concatenate lists of things together, this is the concatenate, like appending to a list. And then you get a different type of outer multiplication, right? So by representing matrix multiplication as 3 different functions, 3 separate smaller functions, you can see a whole world of pattern just emerge. And so now let's go to do some demo. Okay. Let's see this. Okay. So, all right. I've got internet. Good. Yes. So you can do things like 1, 2, 3. This is an array. It's a horizontal array. Oops. That's not correct. That's a parser error. But this, it basically performs what it's supposed to do. You can change this into this. It works. You can then you get. Let's try something fun, right? So x, we define x as a 2 by 3 matrix, and we automatically generate. Oops, wrong button. We automatically generate. We reshape and we automatically generate from an array of 6 numbers. So that's 2, 3 row iota 6 would generate x, and what is x? X is this. So that's iota. If we're all Go developers, there's a very good reason why iota works like that. It's basically a generator, and it's influenced by, of course, APL. And you can do things like transpose x, right? And you can do this. So what I'm trying to say is this is an APL, and if you're familiar with the terms and the verbs and the nouns and adverbs, operators and functions, if you're in the APL world, then you get around thinking about neural networks in a very, very different way. So I'll come back to this. Let's go back to the slides. Okay, how do I get back to the slides? Okay, but thinking in APL requires you to think in a very specific way, and sometimes I need an escape hatch. Sometimes I cannot fit everything I need to in the array paradigm of things. I mean, you can probably fit, the things I do, I can probably fit most things into the array paradigm. So sometimes I don't have the brain cells to write things in APL style, so I need an escape hatch. Sometimes I know that writing code in Go will yield a much, much, much more efficient algorithm because I get access to loops and I can access raw indexing and stuff like that. And also, I originally wrote this bullet point was originally written as side effects, but I think this awkward squad is actually more representative of what I want to do. If I need concurrency, I need to get out of my language because I don't want to go redesign my language, right? you should know that this APL is compatible with most standard APLs. It's extended with some of my some things that I added myself. Yeah. So it's not APL, like not like the big name dialog APL or something like that, but it's like my personal APL. And the thing about my personal APL is that I change the language itself very frequently. And I have the confidence in changing the language frequently because I have a fairly sound type system behind all of this. Sorry, where was I? Yes. So let's look at how we define functions in APL to design this escape hatch, right? So to define a function, this is the modern method, and we call this defuncts. Alpha is the first parameter. Alpha is the parameter to the left of a function. Omega is the parameter to the right of a function. So this, we call it a dyadic function. It's a function that a binary function. It takes two operands. So you can see it's basically 1 plus, you just replace alpha with number 1 and omega with the array, and you've got the results. Okay? But this is not how APL functions are traditionally defined. And if you read like A Programming Language by Iverson, he would write something like this. And this is familiar to us, right? This top bit over here. This top bit over here is a function. It's a function signature, and it tells you that this is the name of the function, and we bind the variables to left and right, and then we return the results as left and right. So let's hijack this. Nobody uses this anymore, right? No. Let's say hypothetically I want to release INiGo into the world. We've got to maintain some sort of compatibility. No one's going to write function definitions like this anymore. So we can write this. And so I had a bit of a second thought, so I changed the delta to this symbol. Unfortunately, I brought the wrong keyboard today. I don't have this command key in my keyboard right now. I've got like 5 of these keyboards, and I often bring the wrong ones out for different. Anyway, so point is I can type all these symbols on my keyboard, right? And I forgot to put this symbol in, so I quickly, hastily edited the function, my interpreter, to re-accept this. Okay. Sorry. It's got a name. The name is called command key, but I don't know how to use speech to text on.
You read Snow Crash. You don't want to read it.
Why?
Can this be solved by having 6 fingers on your right?
Have you used the princess symbol?
Sorry?
Princess symbol. Use the one for
What's a princess symbol?
Ankh.
Oh, Ankh?
The Ankh symbol.
Yeah.
Prince.
what's better than that?
It's from Ankh.
Okay, it's a cross with, yeah. What about it?
You want to know if you've used it anyway.
No. The thing is, I have a lot of extra symbols, and every time I add symbols, I also have to add them to my keyboard, like the firmware of my keyboard. So, demo time. Right. So the trick for me was that I
So I support accessibility for people using desktops at work, and yeah, I can't imagine a conversation without line. Yeah, anyway.
I don't know how to find my No. Okay, how do I get out of full screen mode? Right, dumbass. Nope, still dumbass.
Refresh
That's
the
the one.
page.
Sorry?
You can refresh the Google page, and it should take you back to the regular.
Yeah, I'm trying to look for my terminal actually. There you go. So we can continue here, and for example, we can write func I, because I love identity functions. They're the best things ever, right? So what I can do is I can write a function with some known types, the values.value. And as long as the function sticks to one of these two function signatures, it'll be fine. So I'm writing Go code here in my APL. You know what? Okay, point is it works. I can't be asked to type it. The point is it works, and this is an FFI to Go. You can write functions in Go and call it in INiGo in this APL. And this way, and because I'm forced to like obey these type signatures anyway, I'm forced to stick to these type signatures. I can't go too crazy with it. And in this way, it sort of opens up the avenue for problem solving, while not like overly limiting you to only specific to APL kinds of. Yes.
How did you implement that? Did you compile it as a separate thing as a plugin? Or?
Let's find out. Okay, let's see if this internet is good. Okay. The big issue is that it requires internet access. This compiler requires internet access. One of these days, I must go and write a terminal. Anyway, let's try again.
He must write a terminal to finish the thought.
Sorry?
One day he must write a terminal, or is that?
One day I must write a REPL that can allow me to go back up one line.
Did you reuse Acme or something like that?
No, I did not. This was Peter H. Liner. It has Emacs bindings, and that was all I care about.
You should also rename value to V or something instead of something like.
Yeah, but that would break a lot of things. So I will show you how it actually works in a bit.
Vim bindings are off the menu.
Sorry?
Vim bindings are off the menu.
Nope, I don't know Vim, so. All right, so I've got a function that's compiled. It's still running. It's still running. It's still running. You'll know that it's done when it goes into that. It might actually error. Okay, there you go. Aha! I did not return. See, it compiled wrongly. I returned A, and it should be returning A and nil. But point is, this has it calls the Go compiler behind the scenes. What I planned to do originally was to actually include the Go compiler into the language, but that's ridiculously huge. And if you do that, you can't do it the way I'm doing this. So this is a live Go program, and what it does is it compiles that function in a build mode called plugin, and then opens the plugin on the fly. Go mod. So it will have, I will show you. You cannot compile the file without go mod. Yeah, but that requires like people, like in some brain cells to set up, which I don't have any, so. Right. You know, brain fog and all that is real, not a joke. So how it really works is basically a compiler call to go build with build mode of plugin, and then it opens the plugin and calls a function. So we can explore some code, and this is how essentially the compiler works. So the main gist is it will first get the name. It will figure out if that fragment of the code is a valid function, of a valid function signature that I'm looking for. Get name basically checks that make this. Get name basically checks that it's either a monadic function or a dyadic function, right? So that fragment that I wrote, it checks that it's valid. Then we have to compile it. And the trick is to add a header, and this is the header that I add. Concatenate it together, and when Dave said, why don't you just rename it V, that's why. There's a header that knows that V is, you can't do that, right? I mean, I can be slightly more clever and check the selectors and...
You do a type alias in the package.
Oh, damn. Yep. Very clever. Okay. Yep. So what this does is then it'll do a write the Go mod file, which in this case is very specific to this specific build in this specific computer because, like you said, one of the issues was the original repository is called Mango and now it's called INiGo, and so you can see that like there are two redirects, right? So you redirect Mangoes to this and redirect this to that. That's ridiculous, but it's a hacky solution and it works for this specific machine. That will be obviously, this will be obviously made into something more customizable. And then after it writes the Go mod, it will do a Go imports to clean up all the unused imports if possible. So every single function that you write is its own main package, and it's nicely organized in the plugins directory. Yeah, it's nicely organized in the plugins directory. So every time you compile, you need to call go mod tidy, and then go mod tidy will go to the internet and fetch all the packages again.
Why did you run go mod tidy?
Because this is done at runtime.
Go mod tidy only tidies up your sum file.
And also your go.mod file. If you look at my go.mod, I'm very lazy, right? So I just write latest for everything.
Pretty sure there's a minus some argument that says don't go to the internet, but you might be able to use latest.
I don't know about that.
There's
There should be some no internet option, but for now, we're living in the 20th-ish century. We're living in the late 20th century. We've got internet. 56K modems are very fast, much faster than 8400 bauds. So anyway, so basically this is all a hack, right? You can of course replace this with all the Go compiler bits, and it calls go mod tidy, and then it calls go build mode plugin. Now, this is very interesting, right? So if you build go build dot and go build star.go and go build a specific file, they all yield different binaries. And it's labeled different, they're called different versions of the binary. So if you, so let's say the function name was I, right? So it would be I.go. And if I build like dots instead, it will be called main. If I build it with star.go, it will look and organizes the name of the files alphabetically, and you'll be named, the binary will be named after the smallest letter, right? So this caused a lot of issues, but I finally figured out that it just checks the binary name matches the name of the file that you call it on, the build on. And then after that, it opens the plugin and loads the plugin as a .func. And the func is basically this. It's a function, and two getters. You can get a monadic function out, or you can get a dyadic function out. All right. So the lesson learned is, of course, that when you invoke a go build command from a program, it's actually quite fraught. The whole star.go dot, and it's quite magical. Not really well documented. It is documented, but it's not that well documented. Go mod tidy without the internet, well, makes compilation quite slow. It used to be, I had another version of this that only worked on Linux. So part of the motivation of building this is this has to work on Macs, right? So it wasn't until what Mark told me that I think it was previous versions of it that only ran on Linux, and yeah, something funny. But now it works on Macs as well, and that's all I care about, right? So yeah, that's essentially it. And to solve a problem, basically what you need to do is basically think of the same problem in different representations. John Conway from the Game of Life, he came up with, what's it called, the twist and, you guys know that, no? A different notation for knots, knot theory. And as a result, he found a whole set of knots. I know it doesn't sound very interesting, but knots are pretty interesting. Okay? Yeah, so what I'm going to do with this, I'm going to open source it, obviously, eventually. There are some language features that I want to bring in from the previous versions of this, like juxtaposition. So instead of writing A multiply B, I just put them together. It's a multiplication. And then obviously, I'm also going to have to implement this, the partial derivative, which, by the way, is a very interesting functor. And oh yeah, the other thing would be operators, the danger sign operator, which marks, it's an operator basically is a higher order function that modifies a function. So it marks the function as unsafe. So in this case, this function, these three little letters here, would keep modifying that data structure of X itself. Oh yeah, also structs. Because people who write APL, they like to fool themselves into thinking everything is an array. They design specific patterns, but they're actually structs. They're just not named. But more in general, what I'm thinking of is maybe adding a new phrase type to define data types, essentially, in APL. Which, if you notice, APL does not have types. And the rules of thumb of programming in APL is completely 100% counter to what you would consider good practice in normal programming languages. Everything that's considered bad is good in APL, and everything that's considered good is bad in APL. Not a joke, it's a thing, right? Like I said, almost, right? In Python, you say there's one way to do things, right? But in Go, there's one obvious way to do things. In APL, there's like 500 obvious ways to do things. Yeah, and the other thing I'm actually quite excited about is this, right? I can use Go programs in INiGo. I also want to use an APL just like the same way that we use regex. And I'm working on that too. And that's about it. That's all. Anyone have any questions? No? Cool. Yeah, I wrote this I wrote this last night when it was very late, so things got a bit loopy at the end. Right? Okay. No questions on APL?
ATS.
Hmm?
ATS.
Yep. ATS is a programming language. It's a pretty cool programming language. Like clean. Or let's see, what other? This is like naming the esoteric programming languages, right? Jot and iota. Okay, anyway, that's my talk. Thank you for coming.
Thank you very much, guys, for coming tonight. We've still got a few drinks if anyone fancies one before we go, but if not, then I think we're going to go for some kick-ons at all day. Same place as last time, which is just underneath this building. So, yeah, thank you so much for coming.
Thank you, Microsoft, actually.
Oh, yeah, thank you so much for coming.
Simon.